at the second example. Compute the Fourier series of f at x equals x squared on the interval -2, 2. Here we are lucky not to write the next steps. Okay, so here, simple, just like the first one, but remember this is even function, right? Good. So for the even function, first let's find our a naught. Or let me write the formula first. F at x is equals to a naught over 2 plus summation as n equals 1 to infinity an cos n pi x over l plus bn sine n pi x over l. This is what we have. So if that is the case, it means that we first find our a naught, which is 1 over l. But in this case, our l is what? 2. The integral of -2 to 2. The function given, which is x squared. Is that okay? Then cos n pi x over 2. Here, these two cannot cancel the pi, so you bring everything. My a naught. Now let's integrate this. This is also integration by parts. So you are going to use the table, which we said that u and what v. The u should take the one that can be terminated. So which is the x squared. You differentiate, you have 2x. You differentiate, you have what? 3a. You have 2. You differentiate, you get what? 0. So here you are going to differentiate till you get to this point. So first differentiation of, you have cos n pi x over 2. So let's differentiate, integrate this one. Here we are integrating the v side and we differentiate the u side. If you integrate cos, you get positive sine n pi x over 2. And all this is dividing by the differential of this. If I differentiate this with respect to x, you see it will leave with n pi over 2. Is that okay? So here I'll have n pi over 2. I hope you are seeing that. But these two can come and multiply here. So it's better I write this one as 2 over n pi. Okay. The next one too, I'm going to integrate this. If I integrate sine, I'll get cos, but it's negative cos n pi x over 2. If I differentiate this, I'm going to have n pi over 2. And there's 2 here. So I'm going to have 4, which is negative, all divided by n pi squared. Is that okay? Now, how many times did I differentiate this? 1, 2. So I have to go next one because this one goes with it, this one goes with this. So let me the 2. So the last one. So if you differentiate this one 3 times, you have to also integrate this here 3 times. So here next one is going to be negative 8 sine n pi x over 2 all divided by n pi cube. Let's look at this. If you were following, you won't ask how I got this. Look at how I did that. These two will come and multiply the 8 here. Now looking at this one, and why here is n pi squared. Here was n pi. Now it has turned to pi squared because when you do this will come and multiply the n pi. That makes it this n pi here already. That makes it n pi squared. So the next one, the n pi multiply n pi squared. That gives you n pi cube. Now look at what I'm going to do here. So this one doesn't go by this one. It goes by this. This go by this one, and this go by the last one. So you go this way, plus, minus, plus. So if we have another one, there should be another one by 0 times that one will still be 0. That one should have been what? Minus. Okay. What happened here is that, just like I said, that when you have sine n pi, if I start substituting the upper limit and the lower limit, if I put 2 here, here will be 2 over 2, it will cancel, right? Leaving only n pi. By sine n pi, we say it is 0. So whenever you see sine n pi, you should forget about that one because when you even bring it here, it becomes 0. So if you bring everything, you see that it will make your word become very long. So if I put 2 here, these two will cancel, leaving sine n pi. Sine n pi is 0. Here sine n pi also go to 0. So the only thing we will pick here is cos n pi x over 2. That makes your work easy. Is that okay? If that one is agreed, then we can say that a naught is equals to 1 over 2. You see, the first one I forgot the pi. That's why there was pi there. 1 over 2 now the integration of this is what I've done, which is, and I'm saying that this time this will be 0. This time this will be 0 because everything here, because of the sign n pi, it goes to 0. Sign n pi, it goes to 0. So the only thing I have here is negative times negative. That will be positive. 2x times 8, a 4 will be positive 8x. Is that okay? Cos n pi x over 2, and all this is divided by n pi squared, negative 2, 2. So this is what we have. So you are now going to substitute. Okay, so our an, please, this is, so please, this is supposed to be an, not a naught. Okay, so half an to be equals to half uh 8. So I'm substituting. So wherever I see x, I'll put 2 there. So 2 times 8, that will give you 16, right? Cos. So if I put 2 here, I have cos n pi. Is that okay? And this is divided by n pi squared minus 16. But if I put 2 here, see, this 2 is already negative. So the negative and this negative will make here become positive, which will be 16 cos n pi. And this one too is divided by n pi squared. So this is what you have. Please, you make sure that the negative 2 that I put it here, or substitute it here, will not have any effect on the cos, because cos is even function. Is that okay? So here, already I've explained to you that cos n pi is negative 1 to the power n. So I can say that my an is equals to 1 over 2 bracket open negative 1, sorry, 16 bracket of negative 1 to the power n over n pi squared plus 16 negative 1 to the power n over n pi squared. So this is what I have now. Let me clean this side. So after this, I move to, you see, this is 16 and 16. This n pi squared, this n pi squared. It's like they are the same, so it's twice of this, right? So twice of it, or I can factorize the 16 out. Is that okay? If I factor the 16 out, I will have, so this an 16 over 2 bracket open. This and this, if I add them, I'll get 2 1 minus negative 1 to the power n, all divided by n pi squared. Is that okay? This is what you are going to have. So these two will cancel this one, leaving an equals 16 negative 1 squared over n pi squared. So this is for our an. Is that okay? Now, when I finish with that, in fact, I supposed to do the a naught first, but I forgot and I started with the an. So let's do the a naught. My a naught will be equals to 1 over 2 integral. You know, the a naught is just a function, so s squared dx. If you do this, everybody can do that. You have 8 over 3. Is that okay? Good. Now let's also look at the bn. Bn is going to be 1 over 2 integral. This is negative 2 to 2. Okay. Negative 2 to 2 s squared sine n pi x over 2 dx. So what do you think it will be the answer for this? 0, right? For this even, This is odd. Even times odd is odd. So if you integrate the whole of this, you get what? 0. So now, it means that the answers is for an and what? A naught. The bn is what? 0. So let's do the substitution. So if I'm to substitute in here, my f at x, which is equals to s squared, will be approximately a naught over 2. Now our a naught is 8 over 3. 8 over 3 over 2, that will give you 8 over 6. Is that okay? Plus summation as n equals 0 to infinity. Our an, we have 16 negative 1 to the power n, all divided by n pi squared, then cos, let me clean here. Now we have our a already. Cos n pi x, all divided by L. Here L was given as 2. So this becomes the series. Okay, so if they ask you to generate any forms of series, you just be substituting the values. Is that okay?